Fitchburg, Massachusetts, once a manufacturing powerhouse, is now struggling to revitalize its once vibrant downtown. With a diverse population of around 41,000 individuals, the need for affordable, energy-efficient housing has become a crisis. Recently reconnected to the commuter rail trail, Fitchburg offers a unique opportunity to those who can look past vacant lots and see its glowing potential. In response to this crisis, our project, located at 510 Main Street, will provide housing and retail or commercial space to serve the city's ethnic population, all while adhering to the new proposed Mass Energy Zero codes. Applying an integrated design approach, this project will create a highly functional, pleasing, and durable building that minimizes energy usage through good passive design and the utilization of sound engineering principles, all while maintaining comfort and minimizing energy consumption as well as environmental degradation.
Our approach for this project was to create a net-zero, mixed-use, multifamily building providing housing for the diverse population of Fitchburg. It is a direct response to the affordable housing crisis while encouraging business and city regeneration. A connector to the adjacent municipal parking structure will provide easy and secure access to reserved tenant parking, including additional EV charging for the structure. There will be 3 commercial spaces at street level that are highly visible on this prominent downtown corner. Upper-level apartment units will be designed with modern living in mind, such as space for work at home. Each commercial space has a mechanical room in the back, and every space has an exit door to the back to the loading area for convenience. Units are designed to be affordable in response to the current affordable housing crisis in Fitchburg. Apartments utilize space usage with open concept living areas. Each unit would have its own balcony, maximizing daylighting and views. Here are some interior renderings to help visualize the inside space. Rooftop and terrace gardens will provide areas for outdoor living and encourage a sense of community.
The design team has worked with the mindset of net zero energy for 510 Main Street, which is essentially we only want to be using as much energy as we are producing or is needed for the current time. Solar panels are going to be the most efficient since the price of solar panels has gone down significantly in recent years, and the long-term, again, benefits and savings are starting to outweigh, as we see from this chart down here, since 2000. For 510 Main Street, we'll be using the Fitchburg area. For solar panels in general, we used Energy Sage and got a quote from 9 different places for their pay period, money saved, and finance options, and we took their average, and these are the results right here. Here we use PVWatts.com just to get an estimation of 510 Main Street. Here we have the main building, the garage, the building plus the garage, and then for the whole year what their rough estimation of kilowatts per year would be.
We will be using a grid-tied inverter, and so for that we have chosen the Solar Edge inverter, which is found to be very cost efficient and has other benefits such as shade tolerance and individual panel monitoring. This will also allow us to convert the AC into DC, and for our vertical and horizontal distribution of energy, we'll be distributing the energy through the building horizontally through the rising mains, and then vertically into the hallways and into the rooms. Into the hallways, assessing all the rooms. For our elevator system, due to the use of our control systems that we can input in our elevator, we are able to save 35% more energy, and that is the same with our lighting control system, using LED bulbs to save energy, and also using control systems that will shut off any lights or dim lights when there is more sunlight in, so that way less energy is being used at times it is not needed.
Here's a quick snapshot into the market in Fitchburg. This data was gathered from the 2020 census as well as the state's housing websites. As you can see, 65% of the renters earn below the median income, and 46% of those earn less than 60% of the median income. Here we can see the comparison between fair market rents and the maximal allowances for low-income housing. Strictly speaking, fair market rents offer more rental income for potential development, but demographically, this does not represent the low income of the majority of the renting population. There are credits that might incentivize a developer to go all in on low-income housing. Ultimately, a mix of fair market rent and low-income housing might be ideal. Lastly, here's the estimate for the cost of our design, as well as incentives offered by the government and the state of Massachusetts. Massachusetts offers many incentives for renewables. There's over $2 million up for grabs when it comes to incentives. Our structural system is made from cross-laminated timber, which is locally sourced and eco-friendly in both creation and application, while being ultimately biodegradable. Application of high insulation value reduces heat loss or gain, minimizing set air temperatures without taxing the HVAC system. The on-site production of clean energy in both solar and geothermal reduces the building's carbon footprint as well as its relationship with the city grid. The implementation of gray water systems, rainwater collection, and low-flow fixtures allows for reduced domestic water usage. Our construction site presents many challenges. For example, the close proximity to a busy city street necessitates the need to minimize soil disruption. New construction greatly disrupts surrounding environments. From soil excavation to transportation of materials to the assembly of the building, all of these stages tax the environment in which it resides. To mitigate our effects on our site's environment, our HVAC system utilizes a vertical borehole heat exchanger with boreholes at standard sizes of 6 inches, minimizing soil disruption. Because of our applied VRF technology, abilities to recover heat and transfer it to needed zones, paired with geothermal heat exchangers, heating and cooling energy consumption is significantly reduced.
Water sources, VRF, will be on every floor with 2 units per residential floor and 3 units on a commercial floor. Every apartment will have 2 to 4 air handlers in every living space with at least 1 in the hallways on each floor. ERV operates by keeping it 2 air streams, exhaust and outdoor air separate, isolating odor, and preconditioning incoming air, preventing heat energy loss.
To document our building's energy performance, we used Slipstream's Ripple. Ripple allowed our energy performance team to input structural details of our building, like square footage, height of floors, number of floors, glass to wall ratio, and receive outputs from Ripple, like an average EUI for the building. This EUI value was based off of Ripple's recommended R and U values for the insulation and window glazing used on the building.